Yes, hello guys. So we are starting with second corollary from 5.2. Let's look at the formula first. So this is the formula. So it is integration of f dash of x divided by f of x dx is equal to log of f of x plus c. Let me simplify this formula first. So it should be integration of 1 divided by f of x into f dash of x dx is equal to log of f of x plus c. Why I have simplified this is the reason. So there will be a function in the denominator. Its derivative of the same function is going to be in the numerator multiplied with dt. So what you have to do, you have to recognize which function you have to put as t. So if you put f of x equal to t, then you'll derive it with respect to x. So you are going to derive this t with respect to x. So you'll get f dash of x dx is equal to dt. So after that, what will you do? You put t in the place of f of x and dt in the place of this whole thing, f dash of x dx. So that's what you have to do. So main thing you have to find is so you have to do a partial part of this in your mind only. First, to recognize what you are going to put as t, and second, how you are adjusting f dash of x dx equal to dt in this given equation. Okay, we'll solve some problems and you'll understand these. So the first problem of corollary 2 is integration of e raised to 3x divided by e raised to 3x plus 1 into dx. It's a simple problem. So as I said, the derivative is going to be in the numerator only. So we have to see if this fits as t or not. Now what they have done, they have put this as t, then they derived it with respect to x. So differentiation is being done with respect to x. So what they have got, dt by dx is equal to, e raised to 3x has a derivative e raised to 3x into 3. This is a composite function, so that's why it is e raised to 3x plus 3 into 3 plus derivative of 1 is 0. So dt by dx ultimately will become 3 into e raised to 3x. So here you can see that here. Now in the numerator we do not have this 3 over here. So that is why we have taken this 3 on this side. Okay. Also you can do one more thing. You can, after this, you can rewrite this function as 3 e raised to 3x divided by e raised to 3x plus 1 and 1 by 3 outside. Now see, why did I do that is by that I can put dt equal to 3 dt in the place of 3e raised to 3x directly by adjusting this, and you can omit this step. You can do any of these two methods, but I also find this method a bit easier, that's why I've explained it to you. So I'm explaining again. If you want to omit this step altogether, what you do, just write this function as it is, e raised to 3x divided by e raised to 3x plus 1 into dx. As you know, we do not have this 3 over here, so I'm taking 3 by myself, so it is 3 e raised to 3x now, but we cannot take it like that, so I am neutralizing it by dividing the function with 1 by 3. And after this, what you can do, you can put t over here, dt over here, and you'll get a function like this, that is 1 by 3 integration of dt divided by t, and that's it. This is what you have to integrate. So you can use the method which is given in the book as well, and the method that I have just told you. So by the method I have told you, this step won't be there. You're directly got with this step. So after that, you know integration of 1 by t with respect to t, that is dt. Integration of 1 by t is log t plus c. You have to put value of t which we have supposed earlier, which is e raised to 3x plus 1, and you'll get the answer, right? There is a fun fact that you have to see. We always say that integration is a opposite process of the derivative, and vice versa. We'll check it out over here. So if we consider this function 1 by 3 log, just a minute. So if we consider y is equal to 1 by 3 log mod e raised to 3x plus 1 plus c, and if we differentiate this with respect to x, which is dy by dx, so that will be equal to 1 by 3 into 1 by e raised to 3x plus 1 into e raised to 3x plus 0. Here it should have been, I'll just write it properly once again. So this is equal to y, this whole thing is equal to y, so dy by dx will be equal to 1 by 3 as it is. Derivation of log is 1 by e raised to 3x plus 1 into in that we multiply derivative of the inner function, that is we say it phi of t, so it is e raised to 3x into 3, so this is e raised to 3x, okay. Now, and plus derivative of c is 0 because it is a constant. So after this, what we are going to get, we get this 3 cancelled with this one, and we are going to get the same function, that is e raised to 3x divided by e raised to 3x plus 1. So if you integrate a function and then you derive it, you are going to get the same function. So this is what we have got, right? Okay, we'll move to the next one. So this is what we have to integrate. I can see that the bracket that the given function contains is log x minus 1, and in the derivative of that the whole function is 1 by x minus 0. So this function ka derivative is 1 by x minus 0, which is 1 by x only. So it means I just split the given function for you to understand easily. If you consider this as I, what I'll do first is I'll write the function like this: log x minus 1 into 1 by x into dx. Why did I do that? Because I know that this function has this whole thing as derivative. So the thing I have circled over here, you can put it as dt. This function can be put as t, and then you can use the formula. So let's see what they have did. Log x minus 1 equal to t. So they derive this with respect to x, right? You don't have to write dt by dx now onwards. Earlier it was only for you to understand. You can directly write 1 by x dx is equal to dt, right? So you can put it over here, and here you can put as t. So what you have got is integration of 1 by t dt is equal to log of mod of t plus c. Always remember, this is a mod, this is not a bracket. So always write a mod whenever there is 1 by t or 1 by x dx there, or any function you're writing. You always have to write mod only, not a bracket, not a square bracket as well. It's a mod. So mod is a modulus of a function. So you'll get to know it later on. So we have replaced t with log x minus 1, which we have supposed earlier, and that's it. That is your answer. You have to end the problem with C. Let's go for the next one. Now, as I've said, you have to look for the numerator. So numerator contains e raised to x plus 1. So search, is there any function in the denominator which has derivative in the numerator? So you can easily see that e raised to x has a derivative, e raised to x only, and plus x has a derivative 1. So you know that in the numerator, I'll just solve this with the similar method they used to solve. So what I'll do is I'll take t equal to e raised to x plus x. So dt is equal to e raised to x plus 1 dx. So numerator I'll put as t, denominator I'll put as t, and whole of this numerator I'll put as dt. So integration of this is log mod of t, which you can write as log of mod of e raised to x plus x, mod complete plus c. Isn't this easy? So always look for a derivative in the numerator and you'll get through. Good. Next. Yes. So next one is the same thing you have to follow, that denominator का derivative numerator में है क्या. So we know e raised to x का e raised to x has derivative e raised to x only, but in the numerator it is e raised to x minus 1. Again I'll search for x raised to e, that has derivative similar to x raised to n, which is n x raised to n minus 1. So here it will be e x raised to e minus 1. So in the numerator here we do not have e raised to x. Here we do not have that e uh, this one. So maybe there are some adjustment that we have to make. So that is the crux of this problem. Those adjustments are the crux. So basic of this corollary 2, now you understand. You have to understand how to manipulate the given function and how to adjust it. Let's see. So simple thing you have to do is to put the denominator as t, because then and then only we'll understand what we have to adjust. So we have put e raised to x plus x raised to a is equal to t, right? So then we know e raised to x has a derivative e raised to x, x raised to a has a derivative e x raised to e minus 1, dx as it is, dt as it is. Okay, now we do not want this e over here. So what will we do? We have to take this common. What does a common, taking common means? Basically you should understand it's fundamental. So I'll explain it here. So what I'm explaining now is the intermediate step that you can write in the book itself. यहाँ पे कहीं पे जगह होगा तो वहाँ पे लिख लीजिए. So this is basically I am multiplying so what I did, I have multiplied it and divided the function, the whole function. So it means it is neutralized. It's just like multiplying 3 with 2 and then dividing it with 2. So 3 into 2 is 6 and divided by 2 is 3 only. So you can multiply and divide any number to adjust. Similarly you can do add and subtract the same number as well. Suppose 3 is there, plus 2 minus 2 अगर किया, so this will become 5 minus 2, which is also equal to 3. So why we do it? So that we can adjust it and make the given formula, convert the given formula according to our needs. So here we do not need e over here. That's what we have to take e common. So I'll explain again. So what you have to do, so you multiply and divide. Then you separate them because it's a common base. Right? So here you can see this e gets cancelled with this, right? And the important thing I have to explain here is the power relation. So e raised to x divided by e is equal to e raised to x divided by e raised to 1 is equal to e raised to x minus 1. So as I've explained earlier, in the power relation, if the bases are same, so e is the base, then if the bases are same and they are in division, so you must subtract their powers. So that's why I've subtracted x minus 1, right? So I think it is detailed enough. So that's how that's how they have taken e common. You can rewind, go back and see it again, and simultaneously write in some rough book. Try to feel your try to write the intermediate steps that I'm telling you in the blank space around in the textbook only, so that at the time of revision you won't lose much time. So right, okay, now So so that is what we have. This is the only thing that we have got in the numerator. We don't want this e as well, so that's why they have taken this e on other side. So we can put dt by e in the place of this whole circle thing, right? Okay. Or you can do, you can, as I've told you, you can omit this step and you can write e over here and divide with e over here. ठीक है, and you can put इस पूरे की जगह dt, सॉरी, यहाँ पे अगर e से मल्टीप्लाई कर दिया, e से मल्टीप्लाई अंदर करना है और e से डिवाइड बाहर करना है, और इस पूरे के जगह ये जो पूरा है इंक्लूडिंग दिस dx, इसके जगह dt पुट कर सकते हैं. यू कैन फॉलो एनी ऑफ दिस मेथड, जो भी तुमको सिंपल लगे. ओके, आई वांट टू टेल यू वन मोर थिंग. ओके, see, e raised to x is a function because it includes x. Okay, so this is called as an exponential function. X raised to e is also a function where x is the derivative. This is called as an algebraic function, just like x square, x cube, वो सब. But e you also can say that it is a function only. It's a constant function. It doesn't have the variable. So that is why I can take e common. Okay, that is why I've said, or you can say they also have taken e common here. It's because it's a constant function. So you can take out constant, or it is called as constant function. You cannot do this. Suppose e raised to x into x raised to e is there. You cannot do take common e raised to x and x raised to e. Just remember this. Okay, this is very confusing sometimes, but you cannot take a function which has a variable x into it as common. Okay, so let's move on. So they have put this whole thing as t, and this ये e raised to x minus 1 के जगह उन लोग ने dt divided by e put कर दिया, and that we have to integrate. As I've said, 1 by e is a constant, it has to be taken outside, and then you have to derive 1 by t only, which is log of t, and t के जगह जो भी हमने suppose किया था पहले वो put कर दिया. That's it. So the main thing that you have to remember from this is how to take this e common. Okay, so the power relation is the main crux of this problem, not the integration. Remember this, because anyhow after solving a lots of problems you are going to get how to solve the integration. But this power relation, it sometimes do not come in our mind to solve. So just mark these steps that I have told you to write, or rewind and see it, make a note of it. Okay, let's go for the next one. So this integration of 1 divided by x log x into log of log x. Now you can see this, the log of log x, if you consider as t, so its derivative will be found with the chain rule. Remember the chain rule? So chain rule says that log of log x is there. So this you have to consider as a function, and you have to treat it as x. So लॉग एक्स का डेरिवेटिव 1/x होता है, तो लॉग ऑफ लॉग एक्स का डेरिवेटिव 1/log x होगा, एंड देन जो भी अंदर था फंक्शन उसका डेरिवेटिव निकाल के मल्टीप्लाई करना है इंटू 1/x, ऐसा ऊपर होता है. एंड देन द नेक्स्ट स्टेप CL, सो इट विल बी 1/log x इंटू ये पूरा 1/x यहाँ पे होगा, और फिर रेसिप्रोकल वगैरह हो गए, दैट विल बिकम 1/log x इंटू x. ओके, so this they have got with the chain rule. So just remember, by solving the integration, the whole chapter of integration, simultaneously you're revising a lot of formula from the differentiation. Okay, this is a revision part for differentiation as well. So integration is not only important because it has high weightage, it is also important because it reduces your work to revise differentiation. So take your time, but just do it properly, one by one. So it will take some time initially, but it will save a lot of time at the time of exam. And remember this mathematical part, there are two parts for the commerce, which is one is statistics, that is part 2, and this is the mostly calculus and mathematical logic and matrices. So the thing is, those who have prepared properly for this calculus part, they save time, and they can use that time for the statistics part because it includes a lot of calculations. So you give time to this now, and it will save your time at the time of exam, right? So let's get back to the problem. So after deriving that with respect to x, we have got log of 1/log x into 1/x into dx to dt. So this whole thing we are going to put for this as dt, and this is going to be 1/t. So now I think you have understood this. This is the same thing. See, then the same thing you have to do. 1/t का log mod of t आएगा, t के जगह put कर दो. That's it. Okay, let's go for the fourth one. By looking at this problem itself, you can see 10 raised to x का differentiation क्या होता है? It's like a raised to x, और उसका differentiation होता है a raised to x log a, और x raised to 10 is like x raised to n, right? तो उसका differentiation होगा, just a minute, उसका differentiation होगा n x raised to n minus 1. ठीक है, तो x raised to 10 का होगा 10 x raised to 9, और 10 raised to x का होगा 10 raised to x into log 10. So this may be a one marker also if they want to treat like that. They won't, but still you can directly write this as log of the denominator, log of mod of the denominator plus c. So that is the integration. So still let's go through it. So this is just a minute. Okay, so they have put denominator as t, they have derived it with respect to x, so that's what they are going to get. So in the place this whole thing they have put dt, right? And I think that's it. ये ऊपर के लिए ये इधर न्यूमरेटर के लिए t पुट कर दिया, फिर this is what you are going to get 1/t, फिर उसका इंटीग्रेशन log of mod of t plus c, टी के जगह अपना वैल्यू पुट कर दो, इट्स इनफ. Okay, with the next problem. Now so you can see integration of 1 divided by 1 plus e raised to minus x dx is there. So इसका इंटीग्रेशन अगर निकालेंगे तो we cannot see anything in the numerator because e raised to minus x का डेरिवेटिव होता है e raised to minus x into derivative of this minus x, that is minus 1. So that is why it's d raised to minus x का डेरिवेटिव है minus e raised to minus x. वो तो ऊपर है नहीं, तो उसका मतलब कुछ एडजस्टमेंट करने पड़ेंगे हमको. तो एडजस्टमेंट क्या करना पड़ेगा कि इसको करना है सिंप्लीफाई. e raised to minus x को वी कैन राइट एज 1 बाय e raised to x, तो बाकी का वैसे ही रहेगा. इसके बाद इट विल बिकम, उसको क्रॉस मल्टीप्लाई करना है, सो इट विल बिकम, ये ऐसे क्रॉस मल्टीप्लाई होगा e raised to x प्लस 1 डिवाइडेड बाई e raised to x. इसका रेसिप्रोकल जाके ऊपर e raised to x डिवाइडेड बाई e raised to x प्लस 1 बनेगा. ओके, एंड दैट इज व्हाट वी हैव गॉट हियर. So we have got here e raised to x divided by e raised to x plus 1 dx. So this whole has, इसको अगर t कंसिडर किया तो dt बनेगा e raised to x into dx. So वो पूरा जगह यहाँ जाके प्लेस होगा, ये तो t है, तो उस हिसाब से this is an easier problem. Now you can solve this. Now the last one, I think the last one has it's a typical different type of problem. So let's assume that you have to solve this problem 2-3 times to understand this, otherwise it is not a general type of problem, it's very typical, it's one of a kind. Okay,